Here we'll look at how to create a context-sensitive pop-up menu. So the function we'll be working with is called TR Windows Pop-up, and it will create and display a pop-up menu that lists all the Design Framework 2 windows currently open on the desktop. And the menu choice which the user selects from that pop-up menu will become the top window, and that will be part of the callback, is to raise that window. So this is an expansion of the simple menu function that we learned about earlier. It's used here. The difference between that one and this one is that we are automatically collecting the list of choices and then creating the list of callbacks every time the user clicks the bind key. So it's not a static menu, it's a dynamic menu. So we see here the outer procedure is called TR Windows Pop-up. Within that we call HI Display Menu, but before we display it within the display menu we call HI Create Simple Menu. So basically every time we call this, a new simple menu is created. It's got a name, its title will be called Windows, and then if you recall from the simple menu we have two lists. The first list is a list of choices and the second list is the list of corresponding callbacks. So in order to generate that first list we're going to use for each map car and read in the list of open windows from using a function called HI Get Window List. And then the for each map car function will then convert each window ID into a window name. So the net result for the first for each map car is that we get back a list of window names. Now in the second for each map car we're going to go through the same window list just like before, getting the window ID, but rather than just get the window name we're actually going to create a string which is the callback for each particular window, which is called HI Raise Window. So we're going to use the HI Raise Window function and pass in the window number into the window function. So this will return to us essentially a list of strings, each string being an HI Raise Window function for the particular window that matches the window name that the user selects. So the second for each map car generates our list of callbacks. And then at the bottom you can see we set a bind key for the command interpreter that anytime we hit the F6 bind key the TR Windows pop-up menu will be regenerated and popped up for us. We then pick the one we want and that will raise to the top. Now you might want to look at the notes. The notes do cover an example of how to sort the window names. If you have a lot of window names, it may be an advantage for you to have a sorted list if a user is looking for a particular one. That uses a built-in function called alpha-less-p, which is an alphanumeric sort, which will compare two window names. Take a look at that procedure and it's a nice template for if you need to sort other lists of things. You could also supply your own function for comparison if it was more complex data, but for alphanumeric data the alpha-less-p function works fine. Here we'll look at the sort function. The function takes two inputs, the data to be sorted and the comparison function, and updates the list destructively in memory. Basically it reorders it. So it basically sorts the list according to a specified comparison function. If you don't specify the function and just specify nil, it will sort it alphabetically. Now this function does not create a new list, it returns the altered input list. So this is a destructive operation. And the other thing to note in the example here is we are using trGetSortedWindowList, that function we've predefined, in place of the HI Get Window List that we would have used previously. So HI Get Window List just gets us a list of windows. It doesn't care what order they're in. But trGetSortedWindowList will actually call the sort function to sort them according to, in this case, the alpha-less-p function, which is alphabetically. And it will compare not the window IDs, but the window names. Now a note here is that rather than defining a separate comparison function like tr compare window titles,
you can actually use something called a lambda function. And if you look in the notes for this slide, you'll see that the lambda function basically allows you to create an unnamed procedure, but the return of the lambda is actually a function, and that can be passed into the sort function. So again, rather than having a separate procedure like tr compare window titles, you can embed that inside of a lambda function call within the sort command. Again, if you look at the notes, you'll see the example. Here we'll look at dialog boxes. The HI display app dbox function will display a dialog box. And a dialog box is basically a pop-up window that displays a message for the user and allows the user to interact with it. So the boxes ask for confirmation from the user. They display a status message. And then when the user responds, depending on the response, an associated follow-up callback can be executed to do some additional work. So you can see the syntax here. There's several options. We'll be showing you some examples on the following pages, but basically, you can provide what the banner says, like example, the text like first line, second line, third line. You can then specify a callback when they click OK, or depending on the other buttons, apply. You can have different types of dialog boxes and styles, which we'll look at. You can specify the button layout, different buttons, yes, no, cancel, OK, etc. You can also specify your own buttons. You can specify for buttons not to pop down. So when the button's clicked, the form doesn't, or the dialog box does not go away. You can specify a default button. You can specify a location. You can also have additional help for that particular dialog box. So again, its main purpose here is to display it and allow the user to interact with it.
In order to create a dialog box, you will use the HI display app dbox function. And that will create and display a dialog box. The inputs to the function are shown here. They are keyword parameters. We have a name, a dbox banner, a dbox text, a callback, dialog type, dialog style, and button layout. In this case, we're using a function called gensim to generate a unique symbol given an input. The idea here is we're not going to programmatically interact with the dialog box the user is, so we just want a unique name every time, because if we always give it the same name and the box is still up there and the user hasn't gotten rid of it and we pop another one up, it will then have a conflict because it would have the same name. The banners, what appears in the top. The text is what you're communicating to the user. The callback is what you want to happen when the user clicks on the buttons. And the dialog type, there's different built-in dialog types which you'll explore in the lab further. In this case, it's a warning. It depends what type of icon does appear in that box. Then you have a dialog style called modeless. That means it pops up, and if the user does not click on it, they can keep doing work. Here we have an overview of the dialog box callback and button layout. This summarizes what happens when the user clicks the OK or Yes button, as far as the fact that it triggers the callback. So for the ones listed here, OK cancel, yes no cancel would all have a button that would trigger a callback. If you don't need to trigger a callback, you're just informing the user of something, the close help or the close would be the appropriate one to use.
Here are several skill application dialog box examples, which use the function HI display app dbox. The first one here is how to give some important message to my users just before stream in and stream out. So the example code here will alter the callback of the CIW file import stream and CIW file export stream menu to display a dialog box and present the user with a message. Next, how to display a warning or a message when using file new library on an existing library directory. So this example code registers a trigger such that whenever a library is created, it checks to see if the library already exists and then displays a dialog box. The last one here is how to display a hierarchical net name for a selected wire in a schematic. So the process here is that you select a single wire in your schematic and hit a bind key. And then the example code here will display a dialog box showing the hierarchical net name as you see in the snap. So here we are going to look at displaying a list box for the user to interact with, and we'll be using the HI show list box function. So here you can see a little example of that. Basically, it's a list of built-in function names that start with HI display, and the example code is in the notes. But basically, it's popping this particular form up here, and then the user interacts with it by selecting one of the functions and then either hitting OK or apply, and then the callback will display the arguments for that function. So rather than have the user manually type in a function name, we collect them from the environment and display them for the user and then allow them to interact with the list box. And the syntax is shown here on the left. So you can see we have a name for the list box when we create it. We have choices, which is a list of choices. We have a callback. We have a title, which is at the top. You can turn on or off multiple selects, so the user could select more than one thing if you turn it on. The value is the value that's chosen initially. And then there's some additional information as far as app data and having an apply button. So this is the basic use. The note here is when you write your callback, in other words, when the user clicks the button, the function that you write should have two arguments as input. One is OK, which is the status. What did they click? Did they click OK or not? And then the last one is the actual list box data structure. So basically the status is determined, what did they click? And then finally, the list box data structure will give you not only the list of information that was displayed, but also the choice or choices that the user made. So here we'll be looking at a list box example. On the right, you can see the list box is generated and displayed to the user. As input, we provide the list of nets for the particular cell view, which we extract with a data query command, as well as the name of the cell that we're looking at. So in this case, it's MUX2, and the nets in MUX2 are displayed. And then the user interacts with it by selecting a net and hitting OK or apply. And then the callback is simply to print the choice that the user made in the CIW. So typically you'd have something more interesting that it would be doing, but as far as understanding how a list box works, this is sufficient. So if you look on the left, the code is actually shown here. Basically the procedure called tr show list box takes in a list, which in this case is a list of net names that we've passed in, and then a title. But again, it could be any list, it could be any title, and then it will simply go ahead and generate a list. It'll call HI show list box. We use GenSim to create a unique name for the list box. Then we provide the choices, in this case the list that was passed in or the list of net names. We have the callback, which is shown below in the next procedure. You can see they're connected there. And you simply give the name of it with a single quote. The title, which again was passed in this case it's the cell name MUX2. Multiple select means yes, it's turned on, so the user could select multiple nets. And then whether or not we want an apply button. And in this case, we do want an apply button, which you can see is represented in the list box on the right. The note here is arg1 and arg2, basically the two arguments when we write our list box callback procedure are we need OK and the list box. And then basically if we use OK to say what we chose, we clicked OK or apply, and then what we chose in the list box. Okay, and this is a little for each loop because it's multiple select. We could have multiple values, but it's represented by the list box arrow value. And finally, if we didn't click OK, then we just clicked, hey, you click cancel. So those are the two inputs. And so when the user interacts with the list box, this callback is executed. And at the bottom, again, you see the call. We're grabbing the current cell view, passing in the list of nets and the cell name. And if you'd like to see the code that generated that list box, it's in the notes on the slide.
Next, we want to look at standard forms. Forms are very valuable in the environment when you have a more complex set of inputs that the user needs to provide. It's much better to present a form than to have the user enter, say, 5 or 10 or 20 parameters on a command line. So in this case, the form contains a window banner with a generic buttons by default, like OK, Cancel, Defaults, Apply, and Help. You can define other fields and command buttons, and we'll talk about that in some detail here. And then what happens, of course, when you display this form, the user would interact with the form by a mouse or keyboard. You would then be able to access whatever data they updated in the form and have your own skill function perform the callback and the actual action that you would want. So this is an example of an open file form. You can see here we have the buttons on top. We have some different types of fields. The first one is what's called a cyclic field, where the user can click on it and then choose a different library. The next one is a type-in field. It will interact with the little list box field to the right called cell names. So when the user clicks in that little list box field, the callback to that field will actually update the cell name field. Again, another cyclic field for view name. Mode is set up with what we call radio buttons. So when you click on one of the buttons to turn it on, the other one goes off. And then we have a library path file. And that is grayed out. That's one of the things you can do with the fields is you can allow people to type into that field, or you can set it to be not editable, meaning you can display information in it, but the user cannot type into it. Next, we'll look at analyzing a command as far as when the form actually executes the particular command. So as we look at a form, when the user chooses a menu item, there's actually going to be a menu item callback. So if you pick a particular field on that form, like the list of cells, and you click on it, the callback would actually activate for that particular list box and would update the cell name field. Another case is where the user fills in data. Maybe they type in a particular field, like in the file open form. If they typed in the name of a file, the callback would be typically to check that the file exists. Now, if it doesn't exist, it can give feedback to the user and say, identify to the user that that was an incorrect value. Or if it is a correct value, you could set other field values in response to it. And then finally, once the users input the data and the form is, check the fields, the user will click OK or Apply, and that's the callback for the entire form. So if it was, say, to open a file, then the file would appear on your screen, for example. So in order to create and display a form, there's a series of steps you have to perform. The first is you have to create all the fields that will go into that form. One example here shown in step 1 is to use HI create string field. The next step is to actually create the application form itself, which would be a collection of all the fields. So that particular function name is called HI create app form. And then you have a couple of options as far as displaying it. You can just pop up the form with HI display form, or you can present it in a window with an HI open window command. One thing to note here is that when we look at the different types of functions, you can search for them in the skill finder using HI create star, and it will show you all the different functions that you can use as far as creating them. But we'll look at them in more detail in the upcoming slides. Here's an example of a form we're calling file form, and the idea here is when you want to open a file, this window would pop up. It would have a default value, but then you could type in a new value. And what will happen then is it will actually check that the file that you want to view is present in the environment, and if it is, then it will display it in what we call a show file window, which is basically a text window with the information in that window. In order to create the file name field itself, we need to pass the data structure of the file form to the validation routine, so that way it can collect not only that particular field's value, but any other fields it may need. And then we would use the HI get current form function to retrieve the data structure of the file form. So you can see here in the definition of the field, we use HI create string field. We give it a name, a prompt, a default value, and then the callback is tr do field check CB. We say HI get current form, and then the entire contents of the form is passed into our field check callback. And we see we're also going to be able to check that particular value that the user entered in the form using the syntax here, the form arrow tr file name field arrow value. That will actually go out to the form, grab the value of the field that the user entered, and return it to us. And then in this case, we're passing it into the isFile function, and we'll look in more detail here what happens depending on whether the file exists or not. But that's the sort of summary of how this works as far as how the field check can actually access the entire form. Now the actual trdo field check callback function will return T if the file exists and nil if it does not. And the form argument we're getting passed is that of the HI get current form function return value. And then the file name field is the symbol we passed initially when we created the string field in our prior slides. So the overall trdo field check callback looks like this. We pass in the form, we do the isFile check using the syntax for the form, the field value. If it does exist, we echo back a message in the CIW that the file exists, and we return T. Else we echo a message in the CIW that says does not exist, try again, return nil. Okay, so this basically just does the check and returns us a T or a nil. Next, we want to create the file form. And we're going to use HI create app form to create that form data structure. You can see the inputs here are name, form title, callback, fields, help, and unmap after CB, which we'll discuss on a future slide. The form title is file form. The callback is the function tr file form callback. And then we give the list of fields. In this case, we only have a single field, which was that string field we created earlier. If we had multiple fields, we would list them here. There is another variation on this in that the fields by default will just go vertically into the form. There is a 2D option where each field can have its own definition of the location on the form. And in that case, instead of a single name for the field, you would have a sublist in here for each field that would have the name of the field and coordinate information. Next, we'll discuss what happens at the end of the application when the user finally clicks OK or Apply. A callback for the entire form is executed. And the code for that is listed here. It will check the fields and then continue the command. So you can see the name of the function is tr file form CB. We are passed in the form. We test if tr do field check callback returns true. That's the one that checks if the file exists. Then we're going to, and this looks a little strange, but we're going to set the callback status of the form to T, the highlight field to background, and then we're going to view the form. Now the reason we're doing this first couple things of setting the callback status and the highlight field is mainly from the else branch. Because let's say at some point the user entered an incorrect name and it came back nil. Then we do the else branch, and basically what we want to make sure is that if the user enters an incorrect name, that the form does not go away. Right? That would be confusing to the user. They might see a message that said wrong file name, but then all of a sudden the form goes away. So we want to leave the form up. So we say HI set callback status for the form is nil, meaning don't go away. And then we set the highlight field value for the file name field, the one where the user typed in, to what's called error. And what that does, it draws a little red box around it, identifies to the user that, hey, something happened here that you shouldn't have typed in that incorrect value, and then waits for the user to enter a new value and hit OK again. And then let's say on the second time it is the correct name, the field check callback comes back true. Now we want to set again the callback status to T, meaning the form will go away when we do our callback. And then we want to make sure that the highlight field is set to background instead of error. So that first branch again is assuming that potentially we may have typed it in incorrectly in the first place, and it sort of needs to be cleared back to the default value. Okay, once we've got the form created, we need to display it and then interact with it. So the form would display, and there'd be an OK, apply, and a cancel button. And of course, OK or apply means the callback is evaluated. Apply means the form does not go away. And with cancel, no callback is evaluated and the form does disappear. So it's a pretty obvious situation, but we just want to explain where the callback is evaluated.
So what are form field functions? All field creation functions share similar arguments and return the field structure. Here's a table with some common field types that you might be interested in. The first column indicates the field category, if it's a type in, enumerated choice, information, command. The field type then is single line string, multi-line string, etc. And then the actual creation function itself that you would look up. And if you want to look all of them up, go ahead and open up the Skill API Finder and then look for functions that start with HI create and then also contain the word field. So something like the example here, HI create dot star field. And then what you'll do is you'll see a list. You can look at the specific syntax. And again, for more details, you can click on more info to go to the actual manual with detailed information on each of the arguments to each particular form field creation function. So here's some form field examples of some more interesting types of fields. The first is you can create a hypertext field. This could be a link to a reference manual, to additional information that you may want to share with the user. There's two options, simple and advanced. Simple is a single link. Advanced can have multiple links in a little more complex link format, but again, very useful. The other one might be a tab field. Tab field is very useful for dividing a form using horizontal tabs. The scroll bars are automatically added if the tabs exceed a particular number for that given window. So they're very convenient. In this particular case, this might be like a PDK library where it has P cells listed. Clicking on each tab shows you the parameters for that P cell. So that might be a useful way to organize a form. Another very useful field is called a report field. So HI create report field creates basically a field with columns, and then you can also allow it to sort those columns so the user can interact with the form. In this case, sort by library, cell, or view. And then you can also interactively resize columns. So you grab the divider between the column header and you can expand it or contract it to see more or less information in that given report field. Here's some information on specifying form field locations. So within HI Create App Form, there's a keyword parameter fields, and you can just give it a list of field names, in which case they'll appear vertically in any form you create. So fname1, fname2. Alternatively, you can use the syntax shown here, where next to each field name within a sublist, you basically supply the X and Y coordinates where it starts, the width and height of the particular field, and then if there's a prompt, what the prompt width is. In other words, what precedes the field. And then you can see the example here. We've created three fields, a string field, a list box field, and a report field, and they're field 1, 2, and 3. And then we create the app form, and using the syntax we saw above, we say field 1 starts at 2, 2, and this is in the upper left corner of the form. So it goes upper left to lower right. So 2, 2, and then it's a width of 80 and a height of 20, and we're allowing 10 for the prompt. Field 2 is also in the X at 2, but in the Y, it's at position 32. Okay, so it's basically vertically 32 units lower than field 1. The width of the field is 30, and the height is 20, just like the field above it. So it's consistent height, and then the prompt width is 10 again. And finally, field 3, which is our report field, is at X position of 52 and Y of 32. Okay, and then it's going to be basically a width of 30, a height of 20, and then a prompt width of 10. Okay, so field 3 is actually adjacent to field 2 because the X position moved from 2 to 52, but the Y position stayed the same at 32. So it's just immediately to the right of field 2. Here's an example of specifying form field locations. We basically are creating the browser test form in the graphic on the right. That's the upper form, and we're basically creating a string field and a button. Okay, so we have the my file string field and the browser button, and then we're going to create the app form with HI create app form. The field list is going to include the My File string field, which is the file name that we want to open. And then if the user wants to browse, they can click on the Browse button. And what that will do is call the internal function in the callback called DDS File Browser CB. So there's a built-in function that will let you locate the file path using the little pop-up window, and it will fill it in for you. So you have the option of entering it yourself or using the Browse button to locate it. And you can see the syntax here for that. And so this is just an example of where you're specifying the location. As you can see, the My File location starts at 00, upper left corner. It's got a width of 420 and a height of 30. Okay, and then the Browse button starts a little bit past that location because it was 420 wide, the My File field. We started at 430, so it's just to the right of the My File field, and then we specify its basically Y position and then its width and its height. So you can kind of see the example with the Browse button. There is no prompt width, so we don't need to specify that. So anyway, this is a nice example here of a two-dimensional field to create a form with one field adjacent to the other.
So as a skilled programmer, you can create forms with fields which allow users to input data and run custom skill programs. Now, creating the forms typically involves specifying the fields in a 1D or 2D format using the HI create app form function. And specifying the fields for a large form can be a tedious process involving many coordinates and also provides little control over how the form and fields react when interactively resized by the user. Now, the new HI create layout form function and related functions allow you to specify separate layouts or frames within your form in a modular format, giving you improved geometry management. You can also specify how the form and fields react when the form is resized by the user. Now, once these forms are created, if you want to access the fields in the form, you can use the syntax of the form arrow, the top frame arrow, subframe arrow, field name arrow, value. You can also toggle an entire frame on or off by setting form arrow top frame arrow subframe arrow invisible to T or nil. Now let's take a look at for a moment at the flow that you might use to create these. So first of all, you're going to create the modular parts or frames of your form using HI create form layout or related functions. Then you're going to create the top form by specifying the various frames that you created in the previous step using the HI create layout form function. And then you can also use the size policy option to determine how the user can size or resize the form when they're using it. And finally, you'll display the form using HI display form, and then you can interact with the form and resize the form to see how the resizing works.
Here we'll look at how to create forms using the skill HI create .star layout functions. So the functions to do that are listed here. The top one, HI create layout form, actually creates the form. And into that function, you would pass one of the layouts from the following ones. So you could use HI create form layout, HI create grid layout, HI create horizontal box layout, HI create stacked layout, and then HI create vertical box layout. So any of those and all of those can be combined and create the top level layout form. So in the example here, what we're looking at is the ability to create two form layouts. Basically, we're specifying what they're going to look like. In this case, First one's going to be to just enter some info, as we call it, including the username and the email. Those are both string fields. In my subframe 2, the next code box there, we're going to be creating the my file layout. We'll be have again 2 string fields, this one for file name 1 and one for file name 2. So both of those are now form layouts. Now we're going to create a top frame, as we're calling it, HI create form layout, and that will basically include an additional string field called project, and then the 2 subframes that we created earlier. So my subframe 1 and my subframe 2. And so we simply list those, okay? And then those essentially create the form. They create the form layout comprising those, the string field and the 2 subframes. And then we create the top layout form with HI create layout form. We pass in the top frame that we created previously. And then here we're specifying a size policy expanding. So this is a nice feature, basically making this type of a layout very useful to you, because the user can resize the form as they need in their particular application, interactively as they need to. So this is this is sort of a simple example showing you a couple of subframes, a top frame, and then the creation of the layout form by including those, and then specifying the size policy as expanding. Here we'll look at creating horizontal and vertical box layouts using the HI create horizontal box layout and HI create vertical box layout skill functions. So in the example graphic here, you can see we have a form, and the green boxes show the 3 horizontal box layouts that we're creating. So we create those first. We're calling them search, report, and link based on what they're doing. So the top frame is search, the middle is report, and the bottom we're calling the link frame. And what we're going to do then is, once we create those, we're going to create a vertical box layout and pass into that vertical box layout function the 3 horizontal box layouts we've just created previously. Okay. And then finally, we'll provide that vertical box layout as input to the HI create layout form function to create the actual form data structure. So the nice thing here is, once we create it with these layout related form functions, is we can resize and adapt the form as we need to. And there are some options. If you look in the notes, for example, the code is shown in more detail, and you can specify, for example, that in the center report box, the section which has the report field with the columns has more ability to stretch than, say, the box to the right of it, which is the description. So basically, then you can do some more controlling over the sizing. But in general, the form will size very nicely for the user as far as what they would need, as far as where they want to locate it, stretch it, etc. And so then, and there's some more options that you'll see in both the example in the notes and also in the lab on how to approach that. Here we're going to look at creating a form using the grid layout functions, and the function we'll look at here is HI create grid layout, and we'll use it in conjunction with some of the functions we've learned about previously, which is the HI create vertical box layout, HI create form layout. And what we'll do then is, you can see in the example form here, we've got 2 vertical box layouts, the green boxes, that have labels and cyclic fields and list fields in them. And then we have a center layout there called a form layout, which includes buttons. So you can see, once we create the vertical box layouts and the form layouts, when we create the grid layout, we specify In this case, the left side form, the middle buttons form, and the right side form that we've created previously as layouts as input to the grid layout. And in the grid layout, we specify the row and column locations for these particular layouts. So you can see that, for example, the left side is row 0, column 0. The middle mouse buttons are in row 0, column 1. And the right side is row 0, column 2. Okay, and then again, we provide that grid layout as input to the HI create layout form, which creates the overall form with additional fields, etc., that it needs. But again, this is a nice way to control the formatting of your form very easily. Here are several examples for the skill HI create layout form function that are found on the Cadence Online support site. The first one is how to place the button fields in the center of the HI create form layout frame. And the example uses the question mark spacing and question mark margins options in the HI create layout form function. The second one is an advanced GUI building example using dynamically resizable layout forms. And this example uses the HI create grid layout function in conjunction with other related functions. The third example here is a skill example of a tab field inside of a form layout. How to make another page as the default page. And the example uses HI create tab field and creates layouts within the tab field and shows you some of the example code on how to then make it another page, the default page or the default tab. And then finally, the last one here is how to use the HI .star layout functions to create modular and resizable forms. And the example shows you using how to use the HI create form layout to create several form layouts and then place those inside of the HI create layout form function. And then also shows you the size policy expanding option that allows the user to resize the form.
Here we'll look at toolbar customization. Toolbars are new in the 6.1 environment, and they provide a consistent set of icon menus across windows and applications. They are available for all applications, and here's some examples. First, we have the schematic, and we have a file and an edit menu. And then we also have, for the layout, we have a file and an edit menu. And what you can do is customize the toolbars by modifying a definition file. And the default toolbar definition file is located at this path here. It's in your installation directory under Share, CDS Setup, DF Tool, Toolbars, by application, and then the app name.toolbars. So here's an example from the layout.toolbars file. You can see here that it looks pretty much like skill. It starts with a nil, and then there is a name value set up here where we give the name is the LE file toolbar, the text is file, then there's two items, which would be the open and the save that you see up there in the menu bar for the layout file section. And we've abbreviated those here just for space reasons, but we'll look at those on the next page and expand on those so you understand what an item definition looks like. Here is an example toolbar customization file. This is an expansion of what we saw on the prior page where we are specifying the information for the LE file toolbar, the text that will appear as file, and then the items listed here are for the open file and the save. You can see it starts with a nil, the type is action, the name is LE file toolbar open, the text is open, the icon file is the graphic that will appear this is a PNG file. Then the callback is in this case, the skill function that will execute, which is DE file open. And then we also see the same thing for the save, where the file save PNG is specified and the callback is GE save. Here's a summary of the different item types you can specify in a toolbar customization file. The mandatory fields are name, text, and items. There's optional fields which are invisible and tool button style. So the first one is an action field. The second one is a combo box, meaning you can either type in or select something from the field. The third one is a type in only field, where you would type a value in. The next one is a separator, meaning it's a vertical bar that would separate items in a line just for visibility and ease of use. And then the last one is interesting in that you can inherit toolbars from other applications. So you don't have to recreate or copy it over. You can just, for example, inherit the layout toolbars and then add additional items to them. So that's a very powerful feature for sharing or reuse of existing toolbars. So you can customize toolbars using the Toolbar Manager. So rather than manually editing the toolbar file, you can use this Toolbar Manager to create and update the toolbars. The process of using the Toolbar Manager creates a modified toolname.overlay file in your local .cadence/df2/toolbars directory. Now another option other than modifying the definition file, which works well for individual users, or if you were going to do it, I guess, site-wide, would be to have an application that could modify the toolbars with skill code. So to create a toolbar, you would call the HI create toolbar function. The example here is HI create toolbar. We give it a name, a title, and a tool button style. And then the different functions that we can actually use are HI create toolbar combo box, HI create toolbar type in, HI create action, and HI create toolbar separator. So this is in parallel to the items we identified on the previous page when we modified the definition file, but here are the equivalent skill functions. So here's a skill code example for creating a toolbar. First of all, we create the toolbar itself. We say create HI create toolbar, give it the name, give it a title that will appear, and then we give it a button style. Next, we create items for the toolbar. We say, for example, example action equals HI create action. So this will be an item that actually has an action associated with it. We give the name, the callback, which is in this case the skill function for viewing a file. Then we give an icon that we want to appear, and then finally we give a text that would pop up when we hover over it. So once we have the toolbar created and the item created, we then call a function called HI add toolbar item, specifying the toolbar and in this case, the example action we just created. The last step here is to place the toolbar in a particular session window. So we say HI place toolbar, HI gets session window 1, which locates the session window 1 open, and then it adds a toolbar.
So in this module, you learned how to create context-sensitive pop-up menus, create dialog boxes, create list boxes, design and display layout forms, and also create and update toolbars.